right, so let's finish up on finding the domain for these functions. Remember, we only need to restrict those functions that could possibly have division by 0 or has an even root. Those are the ones we need to dial in on. If there is no root, okay, give me a second. Okay. If there is no fraction with an x in the denominator, no fraction with an x in the denominator, if there's no even root, the domain is all real numbers and you can write it either way. If there is no fraction with an x in the denominator, no even root, odd roots are okay, there's no restriction, and your domain is all real numbers. E, there is no fraction with the x in the denominator, no even root. A square is not a root. So there's no even root, no restriction, all real numbers. Part B, it had an even root, and so to work with even roots, you have to take the radicand, the part underneath, and set it greater than or equal to 0 and solve. You do this for every even root problem. And the answer you get are the values that you're going to include in your domain. Finally, we have a fraction and that fraction has an x in the denominator. Okay, we got to do something about that. So what did it say if I have an x in a denominator? How am I going to handle those type for the domain? Well, if it has in a fraction form and an x, a variable in the denominator, we set the denominator to 0 and solve it. The resulting solutions will be excluded from the domain because they give me division by 0. So I have to exclude them. So it said to set the denominator to 0. So let's take this denominator being this part. Let's set him equal to 0. Another one of those wonderful quadratics that I have to factor. So x times x, 3 times 1, negative 3, positive 1. And I'm going to set both of those factors to 0. If you haven't noticed by now, you need to have some good factoring skills for this class. So find something, some kind of supplement online to practice your factoring. So one solution for x is 3, one solution for x is a negative 1. And remember, if we go back, we set it equal to 0, solve it, and then we have to exclude those values from our domain. My pen is being a bit of a pain. Okay, so we are going to exclude both the 3 and the negative 1. So, yep, my domain is all real numbers, but x cannot be 3 or negative 1. And that is one way to write the answer. But we can write the answer another way, and you need to be familiar with both of these representations. I can say the domain is this. I can say what I have at the top, all real numbers, x not equal to 3 and negative 1, but I can also use interval notation that looks like this. Negative infinity to negative 1. Ooh, I'm going to need a little more room. Okay. Negative infinity to negative 1, parenthesis on the negative 1 because I'm excluding it. Negative 1 to the 3, parenthesis on both of those because I'm excluding them. And then 3 to infinity. So notice this breaks it into 3 distinct intervals. This part right here shows me I'm excluding negative 1 because of the parentheses on both. This part right here shows I'm excluding the 3. Parentheses show I'm excluding it. If you were thinking of like a number line, you got a number line, and negative 1 is here, and 3 is here, and those two guys have open circles because they're excluded. But the rest of the number line is okay. You can use any number you want in between and outside of those. So the interval up to negative 1 is negative infinity to negative 1. The middle one is negative 1 to 3. And the one on the right is 3 to infinity. Remember, you always use parentheses with infinity. Some notations also take it one step further, and they like to put a U in between your intervals. All that U means is a union. You take the union of those 3 sets. Take some careful notes on this because it can be a little awkward. Go back and rewatch it, especially on those restrictions. Okay, so let's wrap up this section 2.2 with an application on fuel stations. The number S of fuel stations that sold E85, so I've got a variable S representing the fuel stations that sold E85 in the U.S. increased in a linear pattern from 2008 to 2011, and then increased in a different linear pattern from 2012 to 2015. You can see in the bar graph right below. The two patterns are approximated by the function. Now look at this function. It's a piecewise function. And what we know about piecewise defined functions is we only use one at a time, and we have to figure out what function we're going to use for which values of t. So they're telling me t represents the years, and t equal to 8 corresponds to 2008. So notice on the right-hand side, our restrictions, we're going to use this first equation when t is between 8 and 11. Well, that means it's between 2008 and 2011. That's when we're going to use the first equation. If we're dealing with a year between 12 and 15, then if the year is 2012 to 2015, we're going to use the second equation. Okay, so we got two equations. We know for what years I'm going to use each one. And notice I'm not going to plug in 2008. For the year, I'm going to plug in an 8, a 9, a 10, 11, 12, 13, 14, 15. Those are the numbers I'm going to plug in for t. All right, so let's see what we have here. I want to determine number of stations that sold E85 each year from 2008 to 2015. Okay, I could get an estimate from the graph, just figuring out how high that bar is, but I don't want an estimate. I want to use the equations. So from 2008 to 2011, I'm going to use the first equation, which is 260.8t what else? Minus 439. Okay, for the years 2012 to 2015, second equation said to use it when the time is between 12 and 15. So the second equation is what I'll use, and it's 151.2t. My memory's not that good. Plus 714. Okay, so I'll just do a couple here for you. So for 2008, we're going to plug in an 8. So it'll be 260.8 times 8 minus 439. That's going to give me for 2008. For 2012, I'm going to plug in 12 into the second equation. 151.2 times 12 plus 714. Work on making those calculations. So after making the two calculations, one for the year 2008, which is here, and one for the year 2012, which is here, using the two functions given to me and using them at the right time, you can see the values I obtained. You can see the values for every year. Check your values, and actually check my values as well. Let me know if you have a discrepancy. I think that's it. So good luck with this. Let me know if you have any questions.